Hi there! Today we are going to show you how you can use DeltaStream to create CDC-based pipelines. In this particular scenario, we are going to demonstrate how you can stream CDC events from Postgres into Databricks. We are going to connect a Postgres instance running on AWS to DeltaStream to source CDC events. Process these events in DeltaStream, then write the results to Databricks using DeltaStream's integration. CDC stands for Change Data Capture. So every time there is a change in a Postgres table, such as a row being inserted, a CDC event is generated to represent that change. As changes are made to the Postgres table, a feed of these CDC events is generated. This event feed is what we want to process and then write to a Databricks table. To set up our use case, the first thing we need to do is create stores in DeltaStream for defining the connection to our storage systems. We can do this in the Stores tab. You'll see in the corner there is a Create Store button where you can create a new store. Give it a name, choose the store type, and add URLs and credentials. We've already completed these steps. We have a store called Postgres CDC for our Postgres instance, and a store called Databricks CDC for our Databricks workspace. In the Databases tab, we have also created a database called CDC. This is the namespace for the DeltaStream relations that we'll be creating. Check out our Getting Started video to learn more about creating stores and databases. With the setup complete, let's create the necessary relations to stream CDC events from Postgres to Databricks. We can do this in the SQL tab. In this example, we are going to imagine that we are an e-commerce company and create a stream of CDC events from our orders table in Postgres. This table has records of orders coming in from our website. Behind the scenes, we are using Debezium to generate the CDC events from this Postgres table. The Debezium format includes before and after fields that represent what the row in the table was before and what it's being mutated to. There is also a field called OP, which informs you if this event was a create, update, or delete event. The schemas for the before and after fields represent the actual columns of the Postgres table's row. Since the data is online orders, we have fields for the event time of the order ID, the customer ID, the price of the order, and a Boolean if the order calls for expedited shipping. Let's run the query to create a stream of CDC events from Postgres. Now the CDC stream is up, let's pipe the data into a table in Databricks. The following query is a Create Table as Select query, where we are creating a table that will contain the results of running a select statement. As you can see, the table relation that we are creating is backed by the Databricks CDC store, and we also specify the Databricks table name and the S3 path of where the data will be stored in the Delta Lake. In this query, we are sourcing from the order CDC stream we defined previously. We are only interested in new online orders. So in the where clause, we filter out any orders where the OP field is not C. Then in the select statement, we unnest all the fields in the after field to get the output schema that we want. Let's run this query. The result we expect is that as new rows are inserted into our Postgres orders table, this query will unnest the fields from these Create CDC events and write these rows into a Databricks table. It takes a moment for the query to start running, so let's quickly take a look at Stream 360 to see how our data flows. In our first query, we created a stream backed by our Postgres source table. This stream feeds into the second Create Table as Select query we wrote. This query performs transformations and syncs the results into a Databricks table that the query created behind the scenes. Now that the pipeline is set up, let's hop over to our Postgres client called pgadmin. In here, we have our orders table with 5 columns as defined. We are going to insert some order records into the orders table in Postgres. Here we are inserting 10 orders into our table. Since our DeltaStream query is already running, we expect these orders to show up in the Orders CDC table on the Databricks side. In the Databricks web console, we can see the Orders CDC table that our query has created. Now, if we query the contents of the Databricks table, we can see the results come in. There we go. As you can see, all of the data that was inserted into our Postgres table are now available in Databricks. To recap, we were able to capture changes to our orders table in Postgres as CDC events, extract the fields that we care about, and sync those results into a table in Databricks. While this may seem like a simple use case, this can be extended to much more advanced scenarios. DeltaStream's rich data processing features allows for complex data transformations such as joins, aggregations, and pattern recognition. By applying these transformations to CDC data, users can write interesting applications on real-time changes to your Postgres table. DeltaStream's support for sourcing data from databases like Postgres using CDC and syncing to data warehouses such as Snowflake gives users the flexibility to operate and provide data products in platforms that they're already using. That's it for this video. If you want to try DeltaStream for yourself, a link in the description can be found below to a free trial of DeltaStream.